This video is on identifying monomials. We're going to start with the parts of an expression. We're going to talk about three parts of an expression: terms. Terms are separated by plus or minus signs. A coefficient is the numerical part of a term that contains a variable. And a constant is a fixed number that does not change. It is constantly by itself. So on this algebraic expression, it's algebraic because it has variables. It's an expression because it has operations but no equal sign. I also typed it out. Please note that when powers are typed out, exponents use that symbol right there. It's above the 6 on your keyboard. You'll see that. I also wrote it here because it's just easier to look at. This expression has three terms. 3n squared is one term. Negative 6n is another term. Positive 5 is another term. Terms are separated by plus and minus signs. A coefficient, the numerical part of a term that contains a variable. Your coefficients are 3 and negative 6. A constant. A constant is a number constantly by itself. It does not have a variable to keep it company. It's all by itself here. This positive 5 is your constant. So 3 terms separated by plus or minus signs, 2 coefficients, 3 and negative 6, 1 constant constantly by itself, the positive 5. Those are parts of an expression. Now we're going to talk about identifying monomials. The textbook says a monomial is a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. That's all true, just a little hard for me to remember. So I've broken it down into 3 things to look for. I say a monomial has one term, no variable in the denominator, and no negative exponents on a variable. So let's look at some examples. Number 1, negative x plus 5. Is this a monomial? No, because it has 2 terms, negative x and 5. Example 2, is this a monomial? Yes, there's only one term. There's no plus or minus sign separating it to more than one term, no variable in the denominator, and no negative exponents on a variable. Example 3, is this a monomial? Yes, one term fits all the descriptions. Example 4, is this a monomial? No, it has a variable in the denominator, the variable n. Example 5, is this a monomial? No, it has a negative exponent on the variable c. Later, we're going to learn that that c to the negative 3 power would go down to the denominator, and then we would have a variable in the denominator. So a monomial has one term. What do you think you would call something that has 2 terms? A binomial. What do you think you would call something that has 3 terms? A trinomial. This expression was a trinomial, 3 terms in it. So before we practice some more, one more time, there are 3 rules to remember about monomials. You can only have one term because mono means one, no variable in the denominator, and no negative exponents on a variable. Again, I'm going to have them typed so that you can get used to seeing this is 8f to the second power g. That actually says 8f to the power of 2g, but we could just say 8f squared g. But I also wrote them out here so we can see them both ways. So let's practice. Is number 1 a monomial? No, 2 terms, 17 and negative c. Is number 2 a monomial? Yes, one term. Is number 3 a monomial? Yes, 3/4 is a monomial. Is number 4 a monomial? No, it has a variable in the denominator, t, so it is not a monomial. Number 15? Yes. I'm sorry, number 5 is 15, and yes, it is a monomial. Number 6? No, 2 terms. Number 7? No, variable in the denominator. Number 8? Yes, that is 1 term. Number 9? Yes. Number 10? No, 2 terms. Number 11? Yes. Number 12? Yes. Number 13? No, 2 terms. Number 14? No, variable in the denominator. Number 15? Yes. Number 16? No. Negative exponent on a variable, we'll learn later that simplest form of number 16 would be 6 over m squared, and then we'd have a variable in the denominator. Number 17? No, 2 terms. Number 18? Yes. You may say no, 2 terms, but it's not 2 terms because that is not in simplest form. When I simplify 6m plus 3m, I get 9m, and 9m is a monomial. Thank you.